Lesson 2. Computer Hardware and Storage Technologies. Let us examine the physical hardware that powers our systems. At the heart of the von Neumann model is the Central Processing Unit, or CPU, which executes instructions and performs calculations. Memory plays a crucial role in this process. Random access memory, or RAM, acts as temporary main memory, holding running programs and active data for quick CPU access. In contrast, read-only memory, or ROM, is used to store firmware or bootstrap instructions that must persist even without power. For long-term data, we use secondary storage. Solid-state drives use flash memory with no moving parts, offering faster access and better physical shock resistance than traditional magnetic hard disk drives with spinning platters. We also use optical storage, such as DVD-ROM and Blu-ray, which use lasers to read and write data. When choosing computers, categories matter. Supercomputers offer the highest relative computational speed for large scientific simulations. For everyday users, laptops trade upgrade flexibility for mobility, while desktop PCs often allow easier expansion and cooling for high power. Interacting with these computers require input and output devices. For precise, continuous drawing, a graphic designer might use a graphics tablet with a stylus. Output devices vary by need. A digital projector is most suitable for projecting a presentation to a large audience in a lecture hall. When evaluating visual output, monitor display resolution is the pixel count that determines image detail, such as 1920 by 1080. Conversely, printer resolution is commonly measured in docs per inch, or DPI. Finally, how we interact with systems matter. Graphical user interfaces are often easier for novices due to visual menus and icons, compared to command line interfaces. In specialized cases, eye movement tracking provides hands-free control for accessibility or research applications.